Can you solve one of the hardest questions on the SAT? In the figure above, the circle with center O is inscribed in square ABCD. Line segment AO intersects the circle at P. What is the length of line AP? To solve for the length of AP, what we could do is solve for the value of AO and subtract it with the radius of the circle. That way it would give us the length of AP. First, let's solve for the length of AO. How do we do that? Well, if we draw a diagonal right in the middle of the square, it would create two right triangles. Angle D is obviously 90 degrees, and if this is a square with a diagonal intersecting it, these two triangles would have the same exact measurements. So the value of this angle would be 90 divided by 2, which is 45. Same thing for this angle. So this is a 45, 45, 90 triangle, which is a special right triangle. Why is it special? Well, if the two legs have a length of x, then the hypotenuse would be x root 2. If we apply that formula here, we know that the legs have a measure of 2. That means that the hypotenuse would be 2 times root 2. So that is the hypotenuse, the diagonal, the length of the diagonal. And this line, line AO, is just half of the diagonal. So we divide 2 root 2 by 2. 2 root 2 divided by 2 is a square root of 2. So the length of AO is the square root of 2. Now, how do we find the radius? Well, we know that a side of the square is 2, meaning this line over here, the diameter, has a length of 2. And the radius is just half of the length of the diameter. And 2 divided by 2 is 1, so 1 would be the length of the radius, meaning this length, what is that? Oh, PO has a length of 1. That is the radius. Again, to find AP, we just subtract the length of AO with the radius, which is 1. So that is the length of AP, meaning the answer has to be D.